shall discuss some invertible problems. If f is a function from R to R defined as f of x is equals to 4x plus 3, show that f is invertible and also find the inverse of f. To say this function is invertible, we need to prove this function is on 1 and on 2. Therefore, we shall consider on 1. To prove it as 1 function, we need to assume f of x1 is equals to f of x2, and we need to prove x1 is equals to x2. This x1 comma x2 are belongs to R, this domain. We need to choose any two functions from the domain. Now f of x is given 4x plus 3. So what will be f of x1? It will be 4x1 plus 3 is equals to, what will be f of x2? It is 4x2 plus 3. Therefore, we can cancel 3 and 3. Then we have 4x1 is equals to 4x2 implies x1 is equals to x2. Therefore, we have assumed f of x1 is equals to f of x2. We obtain x1 is equals to x2 for all x1 comma x2 belongs to R. Therefore, this is 1 1. Next, on to condition. So to prove it as on to, we need to assume y is equals to f of x. We need to assume y is equals to f of x, then we need to find the value for x. So y is equals to f of x is 4x plus 3. Our intention is to find the value for x. Therefore, y minus 3 is equals to 4x implies x is equals to y minus 3 divided by 4. Now you see here, for every real number y, we need to choose y from this real number. For every y belongs to R, there exists a x belongs to R such that y is equals to f of x, because here you substitute any real number 1, 2, 3, 4, 0, minus 6, minus 10, minus 12, minus 100. This x will be again a real number, because a real number minus 3 divided by 4 is definitely a real number. Therefore, for all y belongs to this R, there exists x belongs to this R such that y is equals to f of x, or else you can say y is equals to f of y minus 3 divided by 4. Therefore, this function is onto. Since it is 1 1 and onto, it is bijective. If it is bijective, it is invertible. Therefore, we have proved this function is invertible, and also we need to write the inverse of the given function. So if y is equals to f of x, we can say x is equals to f inverse of y. So this x is here, f to the left hand side, it will be f inverse. Therefore, f inverse of y, we can write f inverse of y is equals to x is what? So already this x is y minus 3 divided by 4. Therefore, we can say f inverse is a function from R to R. F inverse is a function from R to R given by f inverse of x is equals to x minus 3 divided by 4. In place of y, we can replace this x. In the right hand side also, it is x minus 3 divided by 4. Immediately after finding this value, you can verify your result. That is, in this function, you can substitute x is equals to 1. So if you substitute x is equals to 1, f of x or y. So if you substitute x is equals to 1 implies f of x is equals to 7. If you substitute 7 here, you should get 1. That is the definition of the inverse function. So this 1 connects to 7, inverse 7 must be connected to 1. 7 minus 3 is 4. 4 divided by 4 is 1. You can verify your answer. Similarly, we have another problem. f from R plus 2, closed interval 4 to infinity, f of x is x square plus 4. We need to show this function is invertible, and also we need to find the inverse of the given function. So this R plus is the set of non-negative real numbers. First of all, 1 1. So 1 1 as in the earlier case, again it is f of x1 is equals to f of x2. So it is x1 square plus 4 is equals to x2 square plus 4. Therefore x1 square is equals to x2 square. So if x1 square is equals to x2 square, in all the cases we cannot write x1 is equals to x2. But here x1 and x2 belongs to R plus, this domain. R plus is the set of non-negative real numbers. For non-negative real numbers, for all x1 comma x2 belongs to R plus, we can say f of x1 is equals to f of x2 implies x1 is equals to x2. Even if this function is from R to this, then this function was not on to 1 1, because x1 square is equals to x2 square implies x1 is equals to plus or minus x2. Therefore here R plus x1 square is equals to x2 square, x1 is equals to x2 on to. So assume y is equals to f of x. This implies y is equals to f of x is x square plus 4. Our intention is to find the value for x. Therefore we can write x square is equals to y minus 4 implies x is equals to square root of y minus 4. So need not to be write plus or minus square root of y minus 4, because this is R plus set of non-negative real numbers. X is from set of non-negative real numbers. Now we need to prove for every y belongs to this, there exists a x belongs to this, such that y is equals to f of x. You can choose the value of y from 4. The first value for y is 4. If you substitute 4, root 0 is equals to 0, a non-negative real number. Next you can choose 4.2, 4.35. For all that value, 5 minus 4 root 1, you will get a non-negative real number. Therefore we can write for all y belongs to 4 to infinity, there exists x belongs to R plus, such that y is equals to f of x, or y is equals to f of square root of y minus 4. Therefore this function is on 1 and on 2, hence it is bijective, hence it is invertible. Therefore f inverse is a function from 4 to infinity to R plus. F inverse is a function from 4 to infinity to R plus, given by f inverse of y is equals to square root of y minus 4, or f inverse of x is equals to square root of x minus 4.